Yeah. Okay. You are not first. You are the third one. We are still looking for no taker. Maybe I shall ask Michael. He says.
Except quite well. Should we start?
Yeah.
It's after the time, isn't it?
It's after 3 minutes.
Who's online? Alan's online. Oh, right. Do you want me to do it?
Yeah.
Hello, everyone. Welcome to Multipath TCP. Thank you all very much for coming. Do feel free. We've got an extremely large room, so feel free to snuggle up the front. I think this is the biggest room we've ever had.
Can you close the door behind?
Thank you very much to Michael for taking the notes. I guess you'll be doing them in the Etherpad. Yeah. So if anybody wants to help out, because you can collaborate in that would be very good. Is somebody able to monitor the Jabber room, please? I don't know if people still use Jabber, but anybody able to monitor it? I guess we'll try and, Yoshi will try and keep an eye on it. When you come to the mic, please remember to say your name, preferably slowly, so that the note taker can note who you are and everybody else who's here can hear who you are. And the usual reminders about the draft names. The blue sheet is going round. I think we're just going to, you want to do both or just one? We'll do both, okay. I should say I'm Philip Erdley and my co-chair is Yoshi. Here's the usual note well. Here's our agenda for today. First of all, just to let you know the status of our BIS document, the RFC 6824 BIS, the protocol. So that has now completed IESG review, and Mia has pushed, our AD has pushed the button. So it's now gone to IANA. So that's been a lot of work by a number of people over quite a period of time. So thank you, and congratulations to everybody who's made it get that far. So I guess it's the IANA and the RFC editor and things, and it will actually be published, I guess, in a month or two's time. So that's fantastic news. So you can see the rest of the agenda here. We've kind of got two bits really. We've got 3 individual drafts to talk about, and we've got a session to talk about the future or potential future topics for the working group. So as always, we have an open mic for news about implementations, what's happening on that with the Linux implementation or with any of the other ones that there are about. So this is kind of the opportunity for anybody who wants to say anything about implementations, what's happening, what any news there is. Sometimes we have several pieces of news, and sometimes we don't. So just pause to see if anybody wants to say anything on this today. Okie doke. Right, let's move on with the agenda. So we've got 3 individual drafts. We've got first up is Marcus, who's here. That's good. To talk about his robust session establishment work. Come on down. We have the instructions for how to make that work.
Hello, my name is Markus Armin from Deutsche Telekom, and today I want to talk about multipath TCP robust establishment. That is something I brought already up at IETF 99, and now I had some time to write it down into a draft, and yeah, I want to present the progress since IETF 99.
You've got your. Do you want to use that?
Yeah. Okay, just to recap what it is about and what the motivation behind. So multipath TCP had this concept of initial flows, which means in the beginning it starts on one path, the multipath TCP negotiation, and if this is successful, then subsequent flows can be established. And robust establishment is about relaxing this a little bit and introduce the concept of potential initial flows, which means we can use all the paths available in the beginning of a multipath TCP session to establish multipath TCP as such. And that means I demand more or less if there is at least one functional path, a connection must be possible in the beginning. And you can see what is the effect when the potential initial flow is applied. So even if the default route, which is usually used to establish a multipath TCP connection, is somehow blocked, disrupted, whatever, then with the potential initial flow, on the, as you can see on the top in the figure, it can even be established. The detailed motivation you can find in the presentation from IETF 99. Okay, what happened since IETF 99? I published a paper together with the University of London about the robust establishment, and we elaborated there that the functionality of potential initial flows guarantees robust session establishment. Second, it improves the handshake latency, especially if there are paths in the game which have a faster round-trip time, faster latency than the default route, as I mentioned, which is usually used to establish a multipath TCP connection. And third, we even have a throughput gain if subflows are earlier available, as it is with the traditional multipath TCP. Yeah. Also, as I mentioned, I published a draft document describing the multipath TCP robust establishment. And I defining there two concepts. That is the simple robust establishment called RoBE-SYM and the extended robust establishment called RoBE-EXT. And both integrate and consider the feedback which I got at IETF 99 and also on the mailing list. It separates first the functionality of guaranteeing robustness, and which is part of the simple robust establishment, and second, the latency throughput improvement, if we can really use all paths from the very beginning and we can merge the flows that I will explain in a minute. Yeah, second, the audience mentioned that the key A, which is part of the multipath capable option, is not available anymore in multipath TCP version 1 from the very beginning. It is first available in the last part of the three-way handshake. So that is something I had to consider when I designed the RoBE-EXT. Then there was a hint that robust establishment should not add extraordinary computing overhead. That is especially important if you talk about a potential Linux implementation. Yeah, and last but not least, the robust establishment should have the same authentication level as multipath TCP has. So it should be secured from attackers and so on. Yeah, now beginning with the robust establishment, with the simple robust establishment, where I have on the left the flow diagram, how it works. So we have a host A, which is initiating the multipath TCP session, and we have a host B, which is the server that we try to connect to. Both are multipath capable, and what is new now that I've also written on the right, we initiate the multipath TCP setup, sending a multipath capable option on all paths. That is different to the traditional multipath TCP, which would only do it on one of the paths, and first after a successful negotiation, it would use a multipath join to add subsequent flows. Then the path which succeeds first, which means it gets a SYN-ACK from host B, is selected as the initial path. And the other one is then, let me check, in step SA6, so on the bottom, it then resetted from the client. So that is very simple. It's a pure client-based decision. So again, recap it. On all paths, we send the multipath capable. The first one which succeeds from a client view is selected at the initial path, and all the other paths are resetted then. and then the traditional multipass join procedure can be applied. Yeah, the pros are, it is simple, it is a sender-side only implementation, it is full compliant to multipass TCP version 0 and version 1. It guarantees robust session setup, at least for multipass TCP version 0. And the setup latency profits from the fastest path in the game. The cons are we are wasting resources when resetting flows, that is obvious. And what we do not solve, or that we have some dependency on, that the multipass TCP version 1 is depending on a successful egg in the three-way handshake. That means the last acknowledgement has to be successfully transmitted, and we are depending on that as well. So we are not solving this. That that has to be happen successfully. That this acknowledgement is arriving at this point. If you have a look on the extended robust establishment, then it's more or less the same in the beginning. So we initiate the multipass TCP setup, sending an MP capital on all path. We select the initial flow based on the fastest path, which returns the SYN egg. So until this point, we are similar to the simple robust establishment, and then it changed. Instead of resetting the flow, we send in step SA 6.2. We are sending a multipass joint cap option. That is a new option I will explain in the next slide. And with that, we are able to merge a potential initial flow with the initial flow, so that we do not waste the resources, that we can use the effort we already spent to send the multipath capital on all paths, and we can directly reuse them. So the pros are, we have a robust session setup for multipass TCP version 0 and version 1. Even we are not reliant anymore on the final egg of the three-way handshake on the initial flow. So that means we can merge potential initial flows to initial flows, even if they are not fully established. Similar to the simple robust establishment, we profit from the latency of the fastest path, obvious. And what is different to the simple robust establishment is that we have very, very early all subflows available, which means we can gain a higher throughput from the very beginning of a session setup. The con is it requires a new multipass TCP option called multipass join cap. How this looks like can we see in the next slide. So on the left, I proposed the option format. Mainly, it includes the key A of the selected initial flow, and a second, an HMAC comprising information about key B, key A, and the key B of the potential initial flow itself. So the key A, the first information on this slide, and that is very important. We assume that we have the same computational effort on receiver side, similar to the multipass join procedure. So there is no difference in that. The key A of the option is used to identify related flows, so identify which initial flow and potential initial flows belongs together. the KB fast hash, which is part of the HMAC, is used to make the relationship between potential initial flows and not yet fully established initial flows. That what I meant, or that is related to the version 1 of multipass TCP, when, for example, the final egg of the initial flow hasn't arrived yet. And then we can make sure that with the KB fast hash of a potential initial flow, we can establish such a flow and we can merge them. And the HMAC itself, so all the other information which is inside the HMAC is then used for authentication purposes, similar to multipass capital and multipass join, so that attackers cannot modify the option or can take over path or sessions of multipass TCP. The detailed explanation of this can be found on the mailing list. There was already some discussion on that, how the option has to look like and which information needs to be inside. And it's also a part of the draft document. So what are the next steps? We have an existing Linux prototype where we implement the idea of potential initial flows into the multipass TCP reference implementation. Unfortunately, it is more or less outdated, so it's more than 2 years old, and all the changes since IETF99, the definition of the simple robust establishment and the extended robust establishment is not part of that. And I recommend an implementation from scratch. So if someone is in the room, maybe from a university, who is interested in that topic, I think this could be a good work for a student, maybe for a thesis, to implement something like this and to investigate it. Another point is which was already brought up on the mailing list is that maybe the signaling, especially for the extended robust establishment, has to be discussed. Maybe it requires a 4-way handshake similar to the multipass join. And also, which is currently not considered in the draft, just as a section, but without any content, how maybe the negotiation for the extended robust establishment can be made and how potential fallback mechanism has to look like. So for sure that are things which has to be discussed, and then in general we have to improve the first draft version. We have to integrate such things like the signaling, maybe the 4-way handshake, the negotiation and fallback mechanisms, and integrate this in the next version of the draft document. Yeah, the goal is that it becomes working group adopted at some time. And also I had some discussion with potential or with interested persons who maybe support in generating the next draft version of the document, but feel free to join us. I hope I have a last, yes. So in the bottom of the slide, I have a link to the mailing list itself. What I forgot is the link to the Git repository where the draft document is available and where it can be edited. So maybe that I will later share on the mailing list. So yeah, get in touch with me, support us. I think it's a very interesting option to extend the traditional multipass TCP, and there are a lot of use cases which can profit from that. So thank you. And feel free to ask now. There are some questions.
comments and questions? Is anyone interested in helping with this work? In terms of, well, we asked for implementers. Anybody interested in implementing it or helping with the further design of it?
What I forgot to mention is one particular use case that I just had in mind is, for example, that there are some discussions of DNS over TCP or DNS over HTTP. In both cases, robust establishment could be something to make a DNS request over such protocols more reliable. That is something, but also in cases when we talk about multipath connectivity on smartphones, for example, that could be something which makes the whole quality of experience much more reliable, much more better, because it's often the case that we are maybe connected to a Wi-Fi which cannot guarantee a successful TCP establishment, or maybe the multipath TCP options are dropped somehow. So that with robust establishment, we can make sure that we can, even if there's a buggy Wi-Fi, that multipath TCP can be established and can use all the paths.
Anna Renström, so I had a question. So you had the two versions of the setup, the simple and the extended.
Yes.
And is one or the other your main target? Or I also noticed the simple one is quite similar in functionality as to what is developed in the TAPS group with the transport services, where you have racing between protocols, but it would be the same behavior, but it happens one level up as opposed to inside MPTCP. I think the effect would be very similar.
Mm-hmm. Yeah, that is a good point. Also something which was raised from Olivier in the mailing list, that there are already similar functionalities, also the happy eyeball. And I think at least we should consider this in the draft, that there are similar functionalities available. But maybe it is good to have something at least described directly in the multipath TCP context. And I'm not familiar with the TAPS functionality, so I have to consider it.
Yeah, so TAPS basically generalizes happy eyeballs also on doing racing on not only on IPv4, IPv6, but also on protocols and interfaces.
Yeah. At least we need a section in the draft which considers such functions.
But of course, the extended mode is different, right? Because that's, I mean, your extended mode for sure would need a protocol modification. The simple mode you could do on top of MPTCP, I guess.
Yes.
Just to kind of echo Anna's question, so you want to keep going with both modes at the moment. That's your intention, is it?
Sorry?
But the two modes, you've got the simple and the extended. You're intending to keep developing both at the moment. That's your.
I'm open and flexible, right. So it depends. Maybe we should have some discussion on the mailing list, considering this. Though that is just a proposal now in the first draft version. It's now a basic to have a discussion, I guess. And if there are good reasons to remove the simple robust establishment from the draft, why not? For sure, the most sophisticated approach is the extended robust establishment, which also promise the best effect and the highest impact on multipath TCP session establishment. So that's why I personally prefer the extended robust establishment, but just to comprise any solution, I added also the simple approach.
So naive question. So let's say someone implement this one. So can you provide some kind of testing environment from your company?
Yes and no. As I mentioned, we have some prototype available, an outdated one, which we developed to produce some meaningful results, in particular for the paper we published. And this one proved that robust establishment is very beneficial. But I'm pretty convinced that we should not share this outdated version because, as I said, it is very buggy and I'm not sure if others can really use it. That's why I propose to develop it from scratch and directly integrate the functionalities of the current draft version. What I proposed at IETF 99 was far away from these two modes, the simple and the extended, what I proposed now. So that's why I would be very happy if someone is in the room who might imagine to work on something like this. Currently, I don't see that we from Deutsche Telekom have really the resources to develop something from scratch again.
Okay, thank you. So next up is Huang, who's remote, and hopefully, I don't think you hit that one, Yoshi, because I think, because the Meet Echo people are supposed to do things automatically. No, you're not supposed to do it, because I got in trouble last time for doing that. Is that right? The Meet Echo people should make it happen, shouldn't they? Magic should happen, and Huang should be. Oh, hang on. I think we've got you online. Hang. We can.
Okay.
Hello.
Hello.
Oh yeah, we can hear you. Excellent.
Okay. Okay. Thank you. So, hi everyone. So my name is Huang, and we will present two proposed options for MPTCP. Next slide. So the first one is the option to specify and request the inactivity terms. Next slide. So let's consider a simple case that the client create subflow MPTCP with MPTCP capable, and then after sometimes it just close the connection, but this only close the subflow. So what the server will do, how long it will keep the MPTCP sessions. So next slide. So in RFC 6824, it does not specify how long the MPTCP host should maintain the idle options session. So let we consider the inactivity term, that is the duration that an MPTCP session has no established subflow. Next slide. So should we recommend a default inactivity timeout? For TCP, it does not recommend a default value for idle connection, but it specifies the keep alive timeout, which is at least 2 hours, and the NAT timeout, which is 2 hours and 4 minutes. That based on the keep alive. Next slide. So there are two use cases to use the options. The first is the host want to keep the session alive through the transient failure. So to do that, it could request this peer for an enough RTO. For this speed, this exchange does not work because NAT somehow might just terminate the connection, but for MPTCP, NAT is not a problem. The second case is to when a highly loaded servers quickly terminate unused MPTCP sessions by just setting locally a small ITO, and it may signal its clients that either sessions will be closed shortly. Next slide. So we start with a simple format, and the main field is inactivity timeout. It's set at 16-bit, and the range is start from 0, which means that the host will remove the session immediately when there's no active subflow anymore. And the maximum value of timeout is 18 hours. The option is indicative, which means that local policy could override these options and is unreliable. But we can improve the delivery, for example, by just sending it multiple times per second or RTT or through the lifetime. Another way is to attach it to a TCP sequence number and let the TCP retransmission handle it. Next slide. So the next option is to rate limit on the subflow. Next slide. The motivation is for the mobile user, they usually have the limited cellular data quota, but they want to use the cellular networks, but still need to limit the cost in terms of money or reserve the data quota if that is fixed. But the client basically cannot control the downstream data. So the solution is that client requests the server a mass sending rate on the subflow. Next slide. So we think of a similar option format, but for the rate, it should be longer to be able to express a longer range, a bigger range. So that we try to use the floating point format of 62-bit. So it means that basically it could range from 0 to, yeah, you can see the value is very big. And this option also indicative and unreliable. Next slide. So we have prototype one experiment that based on the Linux. So we use eBPF to quickly test new MPTCP options. So basically on the client, the BPF program will insert the subflow mass rate option. And then on the server, it will read the mass rate. And then based on the smooth RTT to find the clamp window to limit the amount of data to be sent in that at that moment. And it could be done periodically for example, per RTT to update the window clamp. For example, if the SRTT changed over time. Next slide. So as you can see, we have measured the transfer rate on the second subflow. In two cases, the default with no capping and the red one with the red capping options with this window clamping mechanism at 4 megabit, and it worked pretty well. Next slide. So what about requesting a rate limit of 0? Because it could allow the peer to disable a subflow temporarily. For example, if the client have two connection, Wi-Fi and cellular, but he move between the good Wi-Fi and bad Wi-Fi, or to go out of home, so it can smoothly disable the cellular part based on the Wi-Fi condition. Next slide. So there are others open questions like how to improve the reliability. So it's similar to the timeout option that we can send several times, or we can let the server to respond to the request, maybe with a flag bit. Then what about the duration of rate limit policy? Should we let it until the end of the connections, or allow the client to specify? Because if we allow that, it will occupy more TCP option space. Or we can combine with other use case, like we set one subflow to be in backup mode as long as the network quality is satisfied. We can have specified the traffic ratio among subflows, or we can cap the amount of data instead of the rate. But personally, I think that there are different use cases, and maybe that is too complex if we mix them together. Okay, so that's all for my presentations.
Thanks, Hein. So we've had
Okay.
two proposals.
Yeah. So
are there any comments or questions about them? It'd be good to talk about one and then the other, I guess. So Yoshi's just coming to the.
Hello, this is Yoshi from Forum. About the rate control option. So in this proposal, the sender side caps the window size. But
yes.
I don't know how it is accurate or not accurate. But if the client side control the advertisement window size, to some extent we can do similar stuff. And then, but why you are trying to control at the server side, not client side? Because it's not very accurate.
You means that why we want to control on the server side?
Right, because the client side, if you can control the advertisement window size, to some extent you can control the server rate.
But for the MPTCP, the on subflow share the same window, the receive windows.
Yeah, but you can tweak that part.
Yeah, but that have different semantics.
Okay.
So they, for example, they can be, I don't know, that if you 3-dots it, then that will be just trigger a fast retransmission, but okay.
Because you think you might change the semantics of MPTCP client. Okay, yeah, maybe we can talk offline.
Okay.
One more question, sorry. This is just out of curiosity about the inactive timer option. I'm wondering what was the default current behavior, like a Linux implementation. If you know that, such kind
In Linux, I'm not so sure, but from my experiment and my understanding of the code, then it just keep the connection forever. I said maybe that under the memory pressure they will kick it, but yeah, I think it just keep forever.
I see. That's something.
Comments and questions on either of these? I mean, especially on the second one, we did actually have a fair bit of discussion on the mailing list. So maybe that all got resolved.
Yeah. Thank you.
Okay. Nobody seems to be asking any more questions, so thanks, Hang.
Thanks.
I think it sorts itself out. I think we need to hit people. So next up is Marcelo to talk about this privacy-related work.
Okay. Okay. Hi. In this document with Christophe and Amelia, what we have tried to do is to make an analysis of the potential privacy threats that the multipath TCP protocol has. Right, so the scope here is very similar to what we have done regarding security. That is basically try to understand, compared to regular TCP, whether the use of the multipath TCP protocol introduces additional privacy threats. Right? It's out of the scope of the document to try to perform a general analysis of privacy threats that affect in the same way TCP and multipath TCP, right? The goal here is to understand if, because we're using multipath TCP, we're exposing additional information that would not be visible if we only use TCP. Okay, so basically the goal here is to eventually restore the same level of privacy that you have when you use TCP, when you start using multipath TCP. Okay, so I mean, you can easily see that multipath TCP may have some potential privacy threats, right? Essentially what you're doing is you're exposing multiple IP addresses that whoever is able to observe that particular signaling will be able to bind together, right? So essentially you can conceive two potential privacy threats here. One is regarding movement tracking, right? So because I'm able to observe that the same device is changing IPs, I can actually track where this device is going, right? And eventually, if one particular device is exposing multiple IP addresses at the same time, maybe I can actually have a more accurate position of that particular device because, I don't know, maybe the Wi-Fi has a shorter range, shorter scope, it's a more precise location than a cellular, an IP that is associated to a cellular provider. Then the analysis that we do is we do based on the type of attackers. I mean, you have different types of attackers that are partially on path or attackers that are in all the possible paths that TCP will use. So if we go into the detailed mechanics of the attacks, there are two types of attacks. One when you use MP-capable and MP-join, another one where you use add addresses. These are the two the protocol messages that are susceptible of these types of attacks. Right, so if you're using MP-capable and MP-join, basically if you observe the token that has been exchanged in the MP-capable and you observe the same token in different MP-join messages, you can actually track down that it's the same device that has and bind all these addresses together. Right? In the case of the add address, you can actually bind the addresses containing the add address message to between them, if you have multiple of them, and to the address that is being used for that particular flow where the add address message is being exchanged. Okay? These things are actually not very hard to fix, right? I mean, if you want to solve the add address vulnerability, the only thing that you need to do is to encrypt the addresses containing the multipath TCP message with the multipath TCP connection key, right? With that, essentially, anyone who can observe the first message can actually decrypt this, but you're essentially imposing that the vulnerability is only if the attacker is on the initial path, right? Which is basically the spirit of the whole multipath TCP security. So probably that will restore to a similar level to all the rest of the security features of multipath TCP. If you want to prevent the multipath capable, the MP capable and disjoint based attack, well, essentially what you need to do is to actually change the token for every MP join, right? And you can actually change it in a predictable way, right? So if you do, I don't know, a hash of the address and the key, for instance, that will actually allow you to not expose always the same token and hence restore the privacy features. As I said, I mean, these are fairly straightforward countermeasures. I don't think they're very hard. It's unclear if it's worthwhile doing them, but just for the sake of the analysis. And then probably there are a few other things that we can actually include in the document. For instance, some guidelines in order to make people aware that when you're exposing more addresses, you are exposing additional information. So provide some guidelines when you should be doing that. I mean, if you have 10 addresses, maybe it's not worthwhile exposing all of them at the same time and only expose the one that you are planning to use or stuff like that. Some guidelines like that will create some form of awareness regarding these issues. And that's pretty much it. So I guess the question is whether the working group is interested in doing something in this space or not. And I guess.
Comments and questions?
Hello, Yoshi from Floor. Yeah, I think I understand the motivation. And then, so one question I have is, let's say the attacker monitors multiple points, and then...
Sorry, can you repeat?
Oh, okay. The attacker monitors traffic at multiple points, and then instead of add MP join, they monitor the DSS option, data syncus number. And then if they observe this data syncus number, and if different connection has almost a similar data syncus number, and then the attacker might be infer this connection belongs to the same MPTCP session.
That's a good additional vulnerability. Yeah. I haven't thought about it. Yes, I agree.
Yeah, that means we have to think about security of the DSS option as well.
Correct. To security or at least the DSS option.
Right.
Correct.
Yeah.
Yeah.
That means we are rather than we are enhance MPTCP option one by one, or we might want to think about the framework that encrypt every single MPTCP option. That might be easier.
Why can't you just encrypt the DSS option with the session key?
Yeah, that could be one option.
I mean, I understand. One option that you're saying is, okay, let's provide a framework that provides overall security or confidentiality of the whole thing. The other thing would be, that may be reasonable, is you protect everything with the session key, and you enable different ways of creating the session key. At this point, basically what you have is you exchange it in clear, but if you manage to negotiate that key with some other means, then it automatically protects the rest of the things.
Right.
That could work as well, I guess.
Right. So I don't know which one is better. That's what my comment. Yeah, you are more security guy than me, but that's my.
I mean, the thing is, we have talked many times in the past about doing a secure version of multipath TCP, right? Either combining it with TLS, either combining it with TCP Inc., either combining it with something, right? And that, so that's something that we can take on. Probably if we want to do that, it would make sense to actually provide like a thread analysis for the whole protocol and try to define what are the security goals for the multipath TCP secure version. That's something that probably worthwhile. I mean, if we want to go that path, that's something that we should do. What I was trying to do in this particular document is to actually, because the thing is, if you go in that path, it's a major change in the protocol, right? It's not a minor update. It's like a significant change in the protocol. What I was trying to provide here, that I think it is feasible, is doing minor tweaks for potentially for the future version, or even in a document like this, just simply updating the base spec, because it's really a minor update. I mean, the stuff that I'm proposing here are really, really minor, right? So if I think we need to understand whether it's possible, if we can solve in particular the additional attack that you are presenting here or not. But as I said, these are really minor things, right? So you could actually do this and restore somehow the privacy of the protocol. You could go all the way and actually provide like a full-blown encrypted, more secure version. I think that the time scales for these two things are very different, right? And then the effort that requires is very different. So I don't know if both of them make sense, any of them make sense, none of them make sense. I mean,
yeah, okay, yeah, just that.
Any more comments or questions? Okay.
you could shut down.
Thanks, Russell. So that's the end of the individual drafts. Before we move on to the rest, somebody wanted to come up to the mic and tell us about some work they're doing with HIP and multipath TCP, and tell us about side meeting.
Yes. Adam Whitaker, AX Enterprise. So we've been using multipath TCP for a little bit now in the UAS area. So UAS is part of the thing that they're pushing is multiple radios on a UAS for failover, and it's just seems like an obvious thing to put multipath TCP on the radio because they want to move all their communications over to IP. And part of the work that we're doing has been trying to put HIP underneath multipath TCP. And that has led to some problems, mainly that HIP hides the IP locators, which is what's used for the subflows in TCP. And it's a problem that we've been thinking of, but we haven't been doing anything with, and we don't have the expertise. So I'm opening it up to everyone here that is an MPTCP to hopefully garner some discussion, because we feel like maybe it's something that has to happen at the MPTCP side or HIP side or both. And we're not sure where it merges together. So tonight at 6:10 in room C2 on floor 21, we're having a HIP side meeting. It's mostly based on trustworthy multi-purpose remote ID, which is our current focus, but because we've been using MPTCP in the UAS spectrum, we'd be more than happy to chat, get comments, suggestions, etc. So feel free to stop by and say hello.
So that's tonight at 10 p.m.?
Tonight at 6:10.
Oh, 6:10.
6:10, yes, 610.
Yeah. Could you send an email if you have?
Yes, I can definitely send an email. The problem I'm having with HIP and multipath TCP, I'll be opening a post on the mailing list later tonight to start discussion there as well.
Thanks, Adam. So we're now moving on to the topic 4 on the agenda, about the future of the working group. So I've got a brief summary to talk through, but basically there's lots of time for an open discussion about this. And just to note that in the TSB area meeting on Thursday afternoon, there's a little time slot there to talk about where multipath work should be done in the IETF in future. So clearly this discussion today impinges on that a bit. And that topic on Thursday is slightly broader because it includes things like multipath quick as well. So that's one for information to go along to the TSB area meeting if you want to contribute to that discussion. Right, so the future of the working group. I guess the default, we've talked about this a bit before, about having largely, we have now completed what we got rechartered to do, so which the main item was to develop a BIS version of the protocol. And that's now in the kind of final editing with IANA and the RFC editor, which is great, but that doesn't mean we've basically completed what we set out to do in the recharter. So we need to think about what to do next. The default, having completed the charter, is that the working group ends and closes. Sign off in triumph and declare success. There would be some minor extensions and maintenance work that might still need to be done, and TCPM will be an obvious place to do that. So having said that, that's kind of the default of what would happen, which would probably happen in about the meeting cycle time. The working group, having discussed this with our AD, Mia, the working group can continue. There's not a problem with doing that, but there clearly need to be active items to progress in the working group. And that really means that there needs to be multiple people involved to do the design and the documentation and the reviewing, and and somebody who's going to implement the idea as well. And I guess we need more than one kind of small topic that applies to those active items. So, here today and then over the next few weeks, and then before the next IETF, we need to kind of find out if that is true, and there are a number of active items with a number of people who want to do work on them, or if it's that there's not, and people have there's not that interest at the moment to do active work. So as a kind of point of information, in the next slide we've listed the if you go on the data tracker, the active individual drafts that there are. So these are the ones that the data tracker considers a kind of live documents. I mean, there were several expired drafts that I think people may want to reactivate. We just heard about the one of combining for best security, combining with TLS. I mean, that's no longer an active draft. It was there in the past. There may be other ones as well. So this is the list of active individual drafts. So this is kind of maybe things that people want to take on, and there's a sufficient group of people who are prepared to work on them and develop them. We can keep going as a working group, or whether one or two of these go to TCPM or another suitable home. So there's the robust session establishment stuff that we've heard about today from Marcus, and he made a request for somebody to implement that. There's a draft called initial path selection, which to me kind of sounds a similar problem that he was trying to tackle. So that might be a way of trying to get some extra people working on the same idea. There was the privacy threats that Marcelo just talked about. I've tried there in brackets, by the way, to list the main author, and then I put some affiliations. So after, Marcello's at UC3M, but then I've put the affiliations in brackets afterwards to indicate there is actually already on that one a group of people from different institutions who are all sufficiently interested in this work to have been a co-author on it. There's the work that Sebastian did looking at how to get TFO and multipath TCP to play well with each other, and propose some mods to MPTCP for that. There's Xavier's 5G session continuity work. So it's the 3GPP session continuity stuff. He identified some inefficiencies of getting that to multipath TCP to as the solution for session continuity, and looked at some ideas for overcoming those inefficiencies. There's the two drafts that Hang has talked about earlier today, the inactivity time option and subflow rate limit. Then there's some other work which we haven't heard about today, the extended socket APIs, proposal to extend that API to indicate priority of subflows. There was a proposal from Fei Song to measure one-way latency to kind of help with the scheduler, multipath TCP scheduler. And then lastly, there was another scheduler-related one, about a stochastic optimal scheduler, which is a draft on there. I'm not sure we've ever actually had that presented at a meeting, but that's another live draft, if you like. So that was kind of for information as the list of individual drafts. So we actually have quite a number of individual drafts. But if I can characterize the overall problem, is that these tend to be ones that there's kind of a small group who are interested in it, and it doesn't get that much. It's been hard to grow those from the proposer of the individual draft. I mean, that's not true for all of them, but that in general has been true. So kind of now it's kind of open for discussion really about how people see the future of the working group. If people are happy if we close, if people want to try and pick some of these or some different ones to really get some live work with several different people contributing for the review side, the development of the protocol, the idea, and for implementation if that is relevant to the idea. So the mic is open. And there's some people on Meet Echo as well who want to talk. So we'll go to Montreal first. Marcus.
Yeah, Marcus Arment. So I have several questions. Maybe some of them are related to Mirja as Comfort Area Director. So can you go to the previous slide, please, first? Okay. So in the first point, you raised that maybe minor extensions and maintenance is made at TCPM. My question is, what are minor extensions? For example, today I proposed the robust establishment. Is this a minor extension or is it a major extension? Is this maybe that much relevant that it makes sense to keep the multipath TCP working group? So what are minor extensions, what not? First question. Second question is, in general, we at IETF, we have a lot of multipath related developments with the multipath TCP as such. It's multipath quick. We also proposed multipath DCCP, for example. So in general, would it make sense to, or shall we collect them maybe in one working group, in one multipath working group? Second point. And the third point is, that is also one of the active draft documents you have in the last slide. that multipath TCP is a protocol selected by 3GPP for multi-connectivity purposes. So that's why I want to ask if this part of the liaison between 3GPP and IETF, and for that reason, does it make sense to keep multipath TCP?
Okay, Mia Kulevin, responsibility. Question number one, a minor extension. That's for the TCP/M group to decide on a case-by-case basis. But in general, if you want to add one MPTCP sub-option, I would think that's a minor extension. So basically, everything that's on the list right now are probably minor extension. The only reason to keep the working group is if there's like a long list of minor extensions you all want to do, and then maybe an own working group makes sense. Question number two. Yes, that's exactly my problem. We have all these multipath work, which is discussing different problems, and we want to make sure that we have people exchanging their ideas and not like working on two things in parallel and whatever coming to different conclusions for whatever reason. So that's the main problem here. But that's a discussion I want to have in TSV area on Thursday. And third point. Yes, the 3GPP liaison is very aware of this usage of MPTCP, but they use it as specified. I don't see there are any requests to actually change the protocol, and they can use it as specified. So I think we're good on that part.
Florian, are you following up on those comments? It's just we got
On the third comment, strictly related on 3GPP,
okay.
You practically have two drafts that are dependencies. One of them practically it's in the last call, and the other one which I assume that we're going to conclude it. So from this perspective, the TCP extensions for multipath operation with multiple addresses. So once that one it is concluded, you practically have zero dependencies on this work. So there is no reason.
Florian, can I just make sure I heard what you said? So the 3GPP has a dependency on the
yes,
protocol?
so currently there are two drafts.
Okay.
One of them, the zero RTT TCP convert protocol, it's in the last call.
Okay.
From what I understood. The other one is a main draft that you have it on TCP extensions for multipath operation with multiple addresses, which you're going to conclude it, I assume, by the IETF106. Yeah.
So the way we keep in sync with 3GPP is that we keep a list of dependencies, so we know which documents, which RFC drafts are referenced in 3GPP documents. And there are two references which are relevant to the MPTCP work. One is to the BIS document, which is now approved, therefore we're good here. And the other one is to the TCP converter, which is working TCP/M and is approaching nicely.
Okay. Thank you. So we should have the person in Meet Echo world.
Hi, this is Keith Moore, and I wonder if I would like if someone could maybe get a sense of a room as to how much interest there is in developing a version of multipath TCP that supports encryption. It doesn't have to be in this working group, whether in this working group or a following working group.
We have very big background noise. We are hearing very big background noise right now.
Yeah, Keith, you would need to use your headset.
I'll type it into the chat.
Otherwise, we can't understand you.
Because I don't have a headset.
Can you say?
Yeah, can you mute or the queue again? Because there's a lot of noise. So what he said is he wants a sense of the room if there's support for working on an encrypted version of MPTCP. Keith, can you please mute or leave the queue?
That's good. The Hoover's been turned off. So it was do people support having all the options encrypted to get a more secure version of multipath TCP? That was the question. Okay. Do people want to comment on that? That's probably easier than having a hum, isn't it? People like that idea of working on a more secure version where you encrypt all the options? I'll tell you what, let's have a show of hands. Who would actually want to do some work on an encrypted version of multipath TCP? Actually contribute to the document and analysis for it. So I see Marcelo. Marcelo's going to be busy.
So as an individual comment, and I love TCP, right? I don't want to be mean to TCP, but if you want encryption, use Quick. And they might be working on a multipath version of Quick at some point, right?
The reason why people are not very interested is it will be very complicated.
I'll risk asking a different question. Who would be against work like that being done? Who would think that was a bad idea? Does anybody think it'd be a bad idea? One. Okay. So it's one, a couple.
Oh. Interesting.
Do you want to make it? Do you want to say why, or you don't have to?
I'm interested.
Yes, Nicholas Polera. I just think it'd be too heavyweight to include that much encryption into the different header fields, and we would essentially just be redoing work that's being done in Quick.
So when TCP Inc. has started, so one application for TCP Inc. was MPTCP. But right now, TCP Inc. does not encrypt header, so we cannot use it. But if we modify TCP Inc., then this option might be possible. Any opinion for TCP Inc. expert? Want to say something?
Mia Kulevind again. So there's like basically zero deployment of TCP. I wouldn't want to continue any work before we get any experience out of it.
Any more comments or questions? Either on Meet Echo or in the room? Oh, and Jabba, this one, is there? Right, go on.
Yeah, Alan mentions, so he has proposed TLS plus MPTCP integration some time ago, and it's already has been submitted as an individual draft. And that's one pointer. And then so Aran, do you want to enhance or working on this one again? Revive this one?
Just one last question, Markus, again. Does it mean we will have another meeting at IETF 106, or is this the last one today?
Mark, we haven't made a decision about that because the discussion here is not the end of it. So this is to prompt people. Need to find topics on which people want to collaborate and do work on. If there's lots of topics, then we'll meet in 106, I guess, yeah. If there are none, I guess we won't, or it'll be a short meeting. I don't know. Yeah. Can't decide at this distance, really.
Comment from chat. So Alan mentioned TLS plus MPTCP integration draft has been submitted a long time ago. And then he said, if people are interested in it, I would contribute. I mean, that means probably he can revive the draft and then work on it. And this is relatively easy rather than, building something from scratch, to integrate, to add more security feature in MPTCP spec. And so there might be interesting paths for secure version of MPTCP. Okay, Alan want to say. Alan, please go ahead.
Yeah, hi all. I just wanted to flag up that obviously a lot of people don't want to do encryption at the TCP level, and that's kind of sensible. We've got TCP Inc already. We don't want to go into reinventing the wheel here. But we have TLS, and the proposal we put in that draft I posted a link for was simply to do TLS key extraction and use the keys to engage the TLS, use the keys from TLS to do the session security. It's only like a 4-page draft because that's all you need to do this, and there was an extra MPTCP option. I haven't thought about how it works with V1 because this was still a V0 thing, but if there is an increased interest in doing encryption, I would like to propose that as a starting point for it.
Mia Kulevin, so if there is any interest in this proposal, I would strongly recommend to bring it also to the TLS working group.
Sorry, no. I mean, this has nothing to do with TLS. I mean, TLS is used as it is. You just extract the key and use the key to feed it to so. Right.
There is on purpose no interface to extract the key. So if you propose them to have such an interface, they will not be happy about it.
Of the people in the room or online, is there anybody who's would be interested in helping Alan revive this work and working on it? Anybody interested in it? There's at least Yoshi. I think the Louvain guys have been interested in the past.
Olivier is the author of the draft, so probably was interested in the past since he wrote it.
Okay, any more comments or questions? Hey.
Eckhard Bogenfeld, Telecom, Germany. I have a question. Could it be that a lot of people are in holiday, and so because you have a lot of individual drafts, what we have seen, and I see in not so much discussion today, but in Prague we see a lot of discussion, more discussions, I remember. So maybe it is only a bad day. Yeah. So I propose not to close the working group and to wait until the next meeting, IETF 106 maybe. Yeah.
Mia, do you want to comment?
Yeah, Shrigan Valley. I'd like to echo that comment. I think if you go back to the next slide, please. So many of these proposals, I remember, we have discussed this over several IETFs, right? But when we took the consensus of the room, there was general interest for doing that work. So now I think, but we haven't properly closed it, right? Whether we haven't issued an adoption call on any of those work items, right? So my recommendation would be like, delay this decision. I think whether to do this here in some other group, it's your decision. But some of these work items have relevance, in my opinion. So maybe instead of 106, maybe move this discussion. Let's make sure there's proper participation. Also today, the attendance is somewhat very light. There's also some other BOF going on. I think for multiple reasons, my recommendation would be to just delay this decision.
Mia Kulevin, AD again. So I will not make a decision right now. You have a chance, and we do that for everything, that you can continue any discussion on the mailing list and that we want to confirm anything on the mailing list. So you should do that on the mailing list if you want to do it. Regarding, you just said some of these items have support and they are light. That's great, we can do them. We don't have to do them in this mailing, in this working group, right? But like the more important part is it's not enough. It only you also support it. You need people who are reviewing this, who are implementing this, who are contributing to it, right? If we have 10 items and each of the items has only the authors contributing to it, it's not helpful at all.
Okay, any more? Last call for any more comments, questions? Right, okay. Thank you all very much. See you soon. Enjoy your evening. Bye, everyone.